I thought I'd film my top 5 magnetism demos. Recently I just thought I'd quickly show you, came across something new, looking at sort of all the things you can do with money, and I discovered that actually a dollar has magnetic ink in it. This is some kind of security feature, so with my powerful magnet here I can move the dollar. Now magnetism, it's a piece of physics which is steeped in history, going back to being played with and investigated by the ancient Greeks. In fact, the Chinese used magic since as early as 206 BC. They used it for divination, and then they used it for navigation purposes. This here is a piece of magnetite that I got on eBay, a rather nice piece, big piece, wasn't very expensive. Nice to show the students how you can pick it up with a magnet. There was some belief that there may have been mountains of this at the North Pole attracting compasses, but now we know where the Earth's magnetic field comes from. And really what we're interested in first is showing students how to visualize fields, and how do we see the magnetic field. We can talk about attraction and repulsion and all these things at Key Stage 3, but if most teachers, I would have thought, have sprinkled iron filings above on a piece of paper above a magnet and visualize the field. You may have sprayed it with hairspray, a bit of hairspray on there to set the thing. In fact, I was once at school where the technique was to, I wouldn't recommend this as such, but the technique was we had wax paper. I preferred this because I didn't like the hairspray with my asthma. Wax paper, and the students sprinkled the iron filings, and then we went round with the blowtorch real quick and just heated it. The iron filings set into the wax and it solidified, and it was a really good record. It lasted a long time. I'd stick with hairspray. How else can we visualize a field? Another good one that I'm really keen to show you is my magnetic probe here. And what you can do with this, again, if you take a magnet, I'll use my powerful neodymium here. What you can do is you can show how this changes the field shape. This magnet is free to move here on this yoke, so it can show you the field as you go around the magnet. This is great for any shape magnet, horseshoe magnets, bar magnets, and I'll show you something else you can do with this a little later. Another way of visualizing fields here is to use small compasses around an arrangement. You can either have coils of wire, it's good around a straight wire. You could turn this on, see the compass change, make sure you have it aligned, pre-aligned, so it's not so that they're already aligned the way it would twist. Just got to think about that when you set it up. Here, it's very good just having 4 plotting compasses around a straight wire to show that whenever current flows, we get a magnetic field. When I was a student teacher, I never forget this. This is just a very big paper clip. I've put a bit of paper on it just so it makes it more visible, just a post-it note, just to make it more visible for you guys. And I came into a room and I saw this, a paper clip floating in this magnetic field. You could hit it a bit. And again, this was even before we had the powerful neodymium magnets. These magnets, magnet magnets from the Winchester motor kits, used to be our powerful magnets in schools. And this fascinated me when I first saw this, when I was basically a student teacher. This is a purpose-built magnetic field visualizer. It has the advantage of visualizing the field in 3 dimensions. It came from a science supplier. We'll put the details below. It came with its own magnets. Once you slide the magnets in, what happens is the iron filings, which you get, obviously have to give it a shake, get the iron filings distributed evenly, and then they start to move, as you can see now, towards the poles. But if you really look, you can start to see that the actual field pattern is starting to take shape. I've seen people make these with vegetable oils and iron filings. You can even do some quite clever things with dry bottles and iron filings. Again, we'll put some pictures below of some experiments I did with this. But we thought this was a very good investment, and the students really liked it. You can pass it round, and they can all see the field. It is very well sealed, and the magnet, like I say, just drops in from the top. Demonstration number 2, magnetic levitation. Always found students really intrigued by magnetic levitation. I mean, we get lots of sort of toys. There's these toys here that can lift objects into the field, ferromagnetic objects into the field. There are toys where pens will levitate. I've even seen one recently that was a globe. It looked quite good actually. It was a globe just levitated there. And there's all sorts out there. One of the science suppliers will do you a levitation kit using this pyrolytic graphite. Pyrolytic graphite is a diamagnetic effect, and it will float. I mean, I built my own grid here of magnets. These are cube magnets. It cost me £15 to build this, and then I can't find my smaller piece. It's unfortunate. The smaller bit actually sits in the magnetic minima here in between the magnets quite nicely. This bigger bit does levitate, but I'm going to have to get the table very level for it to stay. But I'll show you in a minute that it is actually levitating, and the students can look along and see that it's above. It is quite good. Going back to the kits you can buy, this kit here, unfortunately, I have to say this, in the catalogue it looked a lot bigger and it was tiny when I got it. I was quite disappointed. But then the other thing is I found not so good with this is that it basically has spherical magnets and they don't actually fit together as well, which is why, I got the idea, don't get me wrong, I got the idea from this. That's why I went and built my array here, and like I say, it was £15 worth of magnets on eBay. Works really well. You can do quite a lot of things with this anyway. The pyrolytic graphite itself you can buy on eBay. It's always eBay, isn't it? But there's some good suppliers out there that will sell you this. There's some really interesting ones. I won't go on about it now, but I'll show you in the notes below the webinar. There's a really good website out there with magic tricks, and someone made, in fact it's the person that made this box for me here I bought some pyrolytic graphite off. They made a really nice, and they cut their pyrolytic graphite shapes into the creatures from Flatland and they float around on top. It was really good, and I'll put the link down below so you can see. Really fiddly, but the most amazing levitation you can see is with the Levitron here. This is a Levitron. They're about £60. I've been spending hours this afternoon trying to get this set up. It does take hours. They're so fiddly. So it's one of those things that it seems better in some ways to show the students videos of this. However, we have had it working in lessons. It takes a while. We've had it set up. Once you've got it set up, it tends to perform well for the rest of the day where you've got it. But let's have a look at a video of it in action, because it's really good, this. I often use the Levitron when I'm teaching magnetic resonance imaging to my BTEC students. I noticed this was used in the Institute of Physics lecture about the same thing, really, medical imaging. Again, I'll put a link below. It's a fantastic lecture if you teach any medical physics. The thing that I find very impressive about the Levitron is this ability that you really are showing true levitation. And what we can do is bring some object like a cup. This is my Liverpool Physics Olympics cup. Bring back the Liverpool Physics Olympics. They were fantastic. And it never ceases to amaze the students. Doesn't stay in the air for too long, but it never ceases to amaze the students. Here we can see a small piece of pyrolytic graphite. My array wasn't completed here, but what you can see is that I can pass an object underneath. It is true levitation. Demonstration number 3. Demonstration number 3 is about really projectiles. So my favourite is the Gaussian gun. Again, you can buy kits for this. It's quite hard phenomenon to explain, and we can discuss that in the notes below, but it's very good about storing energy in fields, and I tend to talk about this when I'm dealing with nuclear binding energy with my A-level students as well, when we talk about energy stored in the field and how we release that energy. I won't fire this across the room here. I've got a video of it close up. But what's really amazing about this is it's really, again, neodymium magnets are so cheap now. You can get these from China, these neodymium magnets, like packs of 10 for about £1. I don't even know how they get them here for that price. The steel ball bearings, again, really cheap. And this is a standard ruler. This is a standard shape ruler you'll see in the close-up video. Such an easy thing to make. You can buy them from the science catalogues. And we'll have a look at a video of this in action now. just be very cautious with these things. They do have quite a punch to them. Now, I've always liked the levitating ring. There was an AQA 6-mark question a few years back about describing this, and it was a fantastic opportunity to get this out, and never really thought about showing it for a long time with students. I'd seen it on an AQA course when I first started teaching physics, and the most amazing 3-day course I went on, and we saw this and I was really impressed with it, and then I totally forgot about it. And when I saw the AQA question, I built one. What we got here is just, and I found this actually, this transformer in the cupboard. It's very thick copper wound. We're going to put quite a large current through this. We're going to do that very quickly as well, just quick on and off on the power pack. And this, the other thing I've learnt as well is this doesn't work with aluminium stands here. Again, we need a ferromagnetic material, kind of pulls in the field lines, concentrates the field, and then we can observe the phenomenon. AC, again, we can talk about this in the notes below, but I press the switch on and the ring levitates. So technically that should have been in the other thing about levitation. However, this is a nice setup, 12-volt power pack. If you move this, now a real word of caution here, and again I'll put my risk assessment and things in the notes below. This is the demountable transformer coil. This plugs into the mains, hence the caution necessary. Again, I don't want to rely on switching the switch on and off. So again, this would normally have a 13 amp fuse in it. I'm going to put a 3 amp fuse in. That's a 3 amp fuse must go in this for the demonstration we're about to look at. I've got this written on here, 3 amp fuse only. I saved this only for this demonstration. It stays in its own box with 3 amp fuses. So, you know, these are all the things we put in our risk assessment, and what will happen is we won't burn this out, and I'll show you what that does in the next video. Well, as you've seen, it flies up in the air quite well. But remember, now you can see that the 3 amp fuse was in there because it blows. I mean, it does its thing before the fuse blows, which is quite good. And the fuse blows, jobs are good, and it's all safe. So 3 amp fuse. It's actually quite interesting. I've not set this up yet. I had it mildly working, but I want to make it so it lasts for a long time. But this is a bus bell. It fires a pin. The pin fires up. I don't have the whole apparatus. I was having a meal around a friend of mine's house, and someone else was there, and I was talking to them about various bits of physics. I like boring people with various bits of physics at dinner. And they ran out to their van and brought this in and said, hey, look, this is what you're talking about. This is a bell. I fit them in buses. And there was a little pin. I've lost the little pin, but nail works. The little pin fires up and hits the bell. Amazing. Technology in action. Just one last thing about the Thomson's ring. These pieces of aluminium were purpose bought for this. There's this piece here, which is the complete circular ring, and I have one here that basically has a split in the ring. And what I've done is I've connected crocodile clips to either side, and I've connected this to a voltmeter on the millivolt scale. And what you can show here is that when I turn on the power here, and I basically get an induced EMF in the ring. Okay, so I get an induced EMF in the ring, and you can actually show that. Hopefully you can see that on the power pack. You can actually see you get an induced EMF in the ring. So, and that was just a new discovery I was made quite recently. Great, again with that question I was talking about from AQA, we'll put that in the notes, I'll show you what I mean. The question was talking about this kind of thing, and they like this idea that if you've got a split, if there's no complete conducting path, you still get an induced EMF in the ring, and this was good for showing that. So Lenz's law, I might as well show you a couple of things about Lenz's law that we were doing. We were using Lenz's law with the Thomson's ring. But this is most schools have these large magnets still. Ours are usually stuck to the metallic shelf. But what you can do is, and we made this recently, we just cut a piece of copper here, and what you can show is as this goes through the magnet. Again, due to Lenz's law, we'll talk about it down in the notes, what's going on to keep the video shorter. Just show you the demos for now, but this actually stops quite quickly. What you can do then is we've cut, you can see just holes in this to limit the eddy currents, and this will oscillate for much longer. Standard way of showing Lenz's law. The next way people usually go on to show Lenz's law is again with copper tubes, and with copper tubes placing in neodymium magnets. Take a very long time to come out. I'll show you a video of doing this with my friend at Lancaster University. We were actually using this pipe here, a cylindrical pipe, because you can get spherical magnets. I can't show you that today because I've lost the cylindrical magnet. We go through a lot of cylindrical magnets. They fly everywhere, you can't find them. This is a cylindrical magnet though. This is a bit big for this pipe, but I'll show you a video where we can slide this basically down metal plates. And again, you don't always have to be on the inside, just on a metal plate. This will actually, again, induce an EMF that causes a current, that causes a magnetic field that will oppose the motion of the actual steel ball bearing. And then more recently, we came across an interesting one where if we have a copper pipe, let me get this out of the way. If we have a copper pipe here, what we can do is take this is a neodymium, you can get them so many different shapes now, and they're amazing things. Word of caution, some neodymium magnets are really powerful. We'll talk about that down in the notes, and I'll show you how these are labelled, because some of them come as 16 plus, and some come as 18 plus actually, the magnets, so be really careful. I don't use neodymium magnets myself, never let students near them. I'll tell you some stories about that another time, about the pain I caused my nose. Anyway, let's get back to what's interesting to show you students. This is an actual ring. It fits on the copper pipe. Okay, let me do that again. Should have got myself a little bit of foam or something. We've broken these already. This one has actually got a crack in it, which is being very careful with. They're very brittle. But this slides down the pipe. And then what you can buy as well with it is an unmagnetized, let me say that again, an unmagnetized neodymium ring. Same metal, it's just not magnetized. Much quicker, much quicker. What you mustn't do, this is how we broke our first one, send this down and then send this one down, because it will actually attract it, pull it up, and the two, they will stick together and it will shatter. These things come together, they shatter. But we were really pleased with that demonstration. We really like that demonstration. Let me just put these, okay, there. So there, there's a few other Lenz's law ones that we can do. I don't want to fill my whole video with Lenz's law demonstrations. It's probably the thing I have the most demonstrations for. One phenomenon, I would have thought. The other thing we use is, I love these things, Japanese yen, 1 gram pure aluminium coins. Again, I will show you my yen slide on a video that's much better that I made. But what's happened here is I've got just a small one that I've made, just a pocket size one here. And what you can do, again, watch the video, it's much better, we'll put the video on. But these magnets, I think, were £5 for these magnets. Watch the video. On the left here we see a normal steel ball bearing, on the right is a magnetized ball bearing. Here's my array again with a yen hovering above, hanging on a piece of string, just to show you it truly is above. Now if we go to a side view, you can actually see what happens. Watch the orientation. The orientation is key here. Once it becomes face on, you see it almost stop dead. You're back. Now, number 4. Very quick one, just magnetic motors. I really like the fact that down GCSE physics and A-level physics, some really good concepts that are, the fantastic things. Faraday, when he first, it's another actual demo we must put down in the notes, a fantastic demo where you can show Faraday's first electric motor. And the story goes that the Prime Minister of the day came along to see this thing and was like, so what, it spins, great. And he said, what use will this be? And Michael Faraday said, I do not know, good sir, but what I can tell you is within 10 years you'll be taxing it. But the electric motor was born. And what I love telling students is the electric motor is in everything, isn't it? Hair dryers, washing machines, everything is using this electric motor. And we now know that even ATP itself and little tails in flagella on bacteria, it's actually the movement of protons, but it's the same thing. It's actually causing little phenomenon to move, and it's all electrostatic or electromagnetic in origin. But this one, it's been around for a long time now. But the neodymium magnets are getting so strong, small neodymium magnets on a battery. I remember when I was first shown this, absolutely phenomenal. Electric motor wire. Again, what I've done is I put a bit of tape. I find if you just put a bit of tape here, it just helps actually show the phenomenon as we spin. Never fails to impress. And there's my electric motor. I've got another type. There's so many different types you can make now. I've got another type I'll show you in a video. Okay, last one from me, demo set number 5. Music. Everyone loves music. Everyone likes speakers, microphones, all these things. Most of these things, certainly in their earlier forms, now everything tends to be solid state, are really based on electromagnetism. Quite simple principles, actually, and really good things to show students. One of the first I was thinking there, because I remember one of the it was the most amazing worksheet. I remember the first worksheet I ever saw on magnetism was about building a speaker. I thought it was fantastic. It took me a while, actually, to sort of get it into a lesson and build it, but this was the basic design. We have a plastic foam sort of bowl, let me get this right, a foam bowl, it's not a cup, it's not a plate, foam bowl, and I've got a paper plate on top here, and what happens is that inside this, you probably can't see, but I'll put some close-up pictures in the notes below. We've got a coil of wire that I've just wound round a piece of paper, a coil of wire, and I've just glued, well in fact I've not glued, I've got some neodymium magnets stuck on the bottom just by putting a washer on the other side that holds them in place. And what we can do with this is that we can turn on, I've got a sig gen here, we can get a tone out of this, hopefully you can hear that. I can vary the frequency. Do you notice the difference here? That's sine wave, I'm using a square wave in this instant. I'm using a square wave here. Your ear responds better to abrupt changes, so the square wave's better. My son, actually, I get a lot of these ideas from my son. He's on a course studying acoustics at Salford University, fantastic course for your students. Really good course where they learn all about waveforms, electronics, everything, lots of good things in industry. But I said to my son, he came home and I was showing him my speaker, and I said, how does guitar pickup work? And he was telling me how it worked, and I said, well, build me one. And we got some Magnetism magnets here, and we've wound some wire around, and all I do is with a jack, got a jack plug here, and a very small guitar amp that you can see. I'll show you a video of this in action, and it literally is this, it is literally this. So with crocodile clips, I'm going to connect my wires here into this jack. It's just a very simple jack I've just pulled apart, just soldered 2 wires on. I connect this to this coil, and again back to Faraday, our dear friend Faraday again with Faraday's law. When I tap my tuning fork and bring it into the field, what you find with this is actually they tend to stick together. I tend to usually hold this in a clamp stand, you'll see in the video. But what happens, what's amazing about this, and it's is actually the field here, the ferromagnetic material oscillates the field, the changing field, of course, cuts the magnetic flux, cuts the coil here, and that induces an EMF, which causes a current to flow. And where this is oscillating at a given frequency, the tone you'll hear on the guitar amp is the frequency of the tuning fork. Fantastic, absolutely fantastic, so simple. My son then went on to make these, and stick them on all his acoustic instruments, just to see what they did, and they sounded really good. I was really pleased. The last thing really is just a bit of a interesting, funny one, I suppose. You can wrap coils of wire around these plastic pots, and I'm going to put the magnetic probe in this and show you what that does on a video now. But the other thing is those spherical ball bearings move nicely with the SIG gens. And here again I put a coil of wire around a test tube. I'll show you a video, and I've put my magnetic ball bearing in here, and again you can get it sort of dance around inside the tube. Retrospectively, if I was doing this again, I'd want to find a plastic tube, because really I'm getting a metal ball bearing rattling around and glass is quite brittle, so really a plastic tube if you could. But anyway, watch the video, get the idea.